All right, so welcome to our fourth class in Physics 101, an 100 level course. Okay, so in this class, we are taking guys projectile motion. Now, today in this class video is divided into 5 categories. The very first category, I'll talk about projectile motion. Second category, I'll talk about resolving initial velocity. Then the third category, which is very important, talk about equations of motion. Then the fourth category, we talk about time of flight, total time of flight, maximum height, range. Then the fifth category, we do some calculation in Physics 101 textbook. Okay, so now let's start with the class. Okay, so what is a projectile? Now, a projectile is a body that is launched into space or air and allowed to move on its own under the influence of gravity. So that is the definition of a projectile. Now, a projectile is different from a projectile motion. A projectile motion is the path followed by a projectile. Okay, so don't confuse both. A projectile is a body launched into the air and allowed to move on its own under the influence of gravity. Then while a projectile motion is the path followed by a projectile. And that, take note, that path followed by a projectile is known as what? It's known as trajectory. Okay, it's known as trajectory or parabolic. Okay, so projectile motion is a trajectory motion or a parabolic motion. Now let's start with this first part, category 1. Now, projectile motion is made up of two independent motion. A projectile motion is made up of two independent motion. The first one is the horizontal motion and the vertical motion. Okay, so horizontal motion is not the motion in the x direction. The vertical motion is the motion in the y direction. Okay, now please take note of this part because it's very important. Okay, because you know why? Because theories back up calculation. Without knowing some important things here, we cannot just proceed to solving questions. Okay, you need to know some important things before we can proceed to solving questions. Okay, so please take note of this part. Now, the horizontal motion, which is the x direction, the horizontal motion, the velocity is constant. Yes, very important. The velocity is constant. Then acceleration is 0. Okay, so in the horizontal motion, there is no acceleration acting on the body. Okay, so please, velocity is constant while the acceleration is 0. But in the vertical motion, that is motion in the y direction now, velocity is not constant. The velocity changes with time. Okay, while the acceleration, the vertical motion has an acceleration, and that acceleration is what? G. And we all know that G always acts downward. Okay, and remember, if you watch in our previous class, about mechanics, I told you guys about coordinates, right? Yes. Okay, so if using the first coordinate, the second coordinate, 0, 9 minus 0, 9 plus. Okay, I told you guys that we should be using this first coordinate. Okay, so according to the first coordinate, going down is negative, while going up is what? Is positive. Okay, yes. So let's forget about the second coordinate. Now, according to the first coordinate, we know that when we go down is negative, going up is positive, right? Yes. And we all know that G always acts downwards, right? And so when we are going downward is always negative, right? So G is always negative. Okay, using the first coordinate. All right, so let's continue. Now, the acceleration acting on the body, the vertical motion has an acceleration. Yes, affected by acceleration, which is G, and that G is always going downward, and G is one negative. Okay, then velocity is not constant. The velocity is changing. Whereas the horizontal motion, is not affected by G, does not have acceleration. So acceleration is what? 0. Okay, now let's move to the second part, resolving initial velocities. Now, look at the diagram here. You find out that, please, everything here is very important with delay bearing and all. Please take note. Okay, so now this ux, that is the velocity, in the x direction, yes, or in the horizontal direction, right? That, or you can say the horizontal velocity. Okay, while this uy is the vertical velocity. Okay, or velocity in the y direction. Now just take note, when a body or when a projectile is projected at an angle to the horizontal. Let's say this is the stone now. Let's say this is the projectile. When a projectile is projected or is thrown, anyone, okay? So when a projectile is let me use the word thrown. When a projectile is thrown at an angle to the horizontal with an initial velocity. Let's say this is the projectile now, and it's thrown at an angle to the this is the horizontal, at an angle to the horizontal with an initial velocity u. Now, according to vector, remember in our vector class, I told you guys some important thing. Please take note of this part too, okay? So now, during a resolution of vector, okay, let's say this is the y-axis, this is the x-axis, and now let's say this is a particular vector at a particular angle. Now we can resolve this vector to the y direction, and we can also resolve it to what? To the x direction, right? So now the body, the projectile is thrown with an initial velocity at an angle to the horizontal. It's thrown with an initial velocity u. Now, this part is similar to this, right? This is the angle, this is the angle. So, okay, let's continue. Let's say, let me just call this u. Now, let me just call it a, for example. Now, we can, according to vector, we can resolve this based on the fact that it's at an angle to the horizontal. We can resolve it to the y-axis, and we can resolve it to what? To the x-axis, okay? So we can resolve this one to the y-axis. We can also resolve it to the x-axis. Now, resolving the initial velocity of this body, resolving this initial velocity of this body to the y direction, to the y-axis, to now be what? The vertical velocity. Now, resolving this one to the vertical velocity or to the y-axis, to now be what? Equals to u sine theta. Remember, the vertical axis we always use sine, while in the horizontal axis we always use cos. So resolving this one to the vertical axis now be what? Use sine theta, because this object is at an angle, okay? Then when resolving to the x-axis now be what? The horizontal velocity now be what? U cos theta. Resolving to this part to be what? U sine theta. Resolving to this part to be what? To be u cos what? Theta, okay? So yes, please take note of this part, okay? The vertical velocity, please take note. Initial. Now, the initial vertical velocity is what? U sine theta. This is the initial velocity. Okay, this is the initial vertical velocity. I don't know if you understand. Initial vertical velocity. You see, this is U1, initial vertical velocity. Okay, so the initial vertical velocity is equals to what? The initial velocity sine theta, while the initial horizontal velocity ux is equals to what? Initial velocity cos what? Cos theta. So please take note of this. It's very important. We are going to use them. Okay. Now, remember the body was thrown with an initial velocity u. Now, when the body finally gets to the ground, it now turns to a final velocity. We know the difference between initial velocity and final velocity, right? So the final velocity, I will come back to this part. Now let's continue. Let's move to the third category. So in summary to this part, the initial vertical velocity is equals to u sine theta. Yes, this uy now, uy is equals to what? U sine theta. Okay, very important. Then the initial horizontal velocity, which is ux, is equals to what? U cos theta. So it's very important. Okay, yeah, very important. Now move to this third part, equations of motion. One that we have horizontal. Normally, we know that we have horizontal motion, we have vertical motion. Now, in horizontal motion, what is the equation of horizontal motion? Or we have we have v equals to, let me use this marker. Okay, we have v equals to what? U plus at. We have we have s equals to ut plus half at square. This is horizontal motion equation. Then we have v square equals to what? U square plus 2ax. Then what about vertical? Vertical will now be what? V. Okay, I'm coming. Vertical. The vertical will now be what? V equals to what? U plus minus gt. A will turn to g, right? Okay, then this distance will turn to what? Height. H equals to what? Ut plus minus half gt square. Okay, then the last part, I'm coming. The last part will now be what? V square equals to u square plus minus 2gh, right? So remember, h turn to h, a turn to g. Okay, so this is I'm coming. So this is the this equation. This is the equations of horizontal motion. Yes, but they are the same thing. Okay, but using different scenario. Okay, so this is the horizontal motion equation. While this other one is what is the vertical motion equations. Now, where am I? Where am I going to? Now, just listen. Okay. Now, let's start with the horizontal. I mean, let's start with the horizontal motion equation. Let's start with this part now. Now, remember, I told you guys that. Okay, let me start with the horizontal now. We are starting with what horizontal motion equation, right? This is the horizontal motion equation, but this one is the vertical motion equation. Now, remember, in the horizontal initial horizontal motion velocity, or let me say, okay, the initial horizontal velocity, yes, the initial horizontal velocity, which is ux, is equals to what u cos theta, right? Yes. Now worry about this u, what are they? They are what? They are what? Remember, this equation is the horizontal motion equation, is the equation of horizontal motion, right? Remember, this velocity is what is horizontal velocity. So whenever we see u here, we place all these things here. I don't know if you understand. This u, we place what all these things here because we are dealing with horizontal motion. While this one, when this other one, we are dealing with vertical motion, right? So in the u in this part, we use this one because this is the vertical initial vertical velocity. So the u here, which is the initial velocity, in vertical velocity, we use this one here. I don't know if you understand. Okay, so now, yeah, so in this first part, let's start with this first part. Okay, where am I going to clean now? Let me just clean up. I'm coming. Okay. Okay, so now let's start now. So this part is very important. Okay, now let's start. Now be v equals to, we are starting with the horizontal motion equation now. Okay, so this u now, this place, please, this u here is still u, is ux. Okay, ux. Why this one be uy? So let me not confuse you guys. Okay, so this is the initial velocity in the s. This is the initial velocity in what, in the y direction. So wherever we see ux, we'll put what u cos theta, right? So now be what u cos theta, right? Now, should I put plus 80? No. Remember, horizontal motion does not have acceleration. Remember, I told you guys that horizontal motion does not have acceleration. That is under projectile. I told you guys, right? So everything here, since acceleration is zero, 0 times 2 will give us 0. So we'll be left with this part. Velocity is equals to u cos theta. Yes, that is okay, that is under the horizontal motion equation, right? Now let's continue to this other part. Now be s equals to what? Remember, ux is equals to what? U cos theta, right? So now be what? U cos theta then times what? T. Remember, a does not in horizontal motion. In horizontal motion in projectile, the acceleration does not have acceleration, so acceleration is 0. So everything here after 0 times t square, we see everything here will be 0. So we'll be left with this. Okay. Now the last part, remember a is t0, right? So everything here will be what? Everything here will be 0. So we'll be left with what? V square is equals to what? U cos theta all squared, right? So yes. So this is now the what? The horizontal motion equation in projectile. So this is the horizontal motion equation in projectile. Now, so please take note. Okay. Now let's derive the vertical motion equation now. Okay. Now remember, I told you guys that uy now is equal to what? U sin theta. So wherever we see uy, wherever we see uy, we'll put what? U sin theta, right? So let's continue. Now be what? Now be v equals to what? Uy will put u sin theta, right? Now, why are we going to use plus or minus? We're going to use minus. Remember, I told you guys, right? Because g always has downward, so g will be minus, right? So now be what? Now be minus what? Gt. Remember, vertical motion. I told you guys in projectile that it has acceleration, and the acceleration is g, which is negative g, and it has downward. So this is why it's negative gt. Okay. Now let's continue. So that be h equals to what? Whenever we see ui, we put what? We put u sin theta. So that be u sin theta, then t, then we put minus half gt square. Okay. Now, then the last part, I'm coming. The last part, should now be coming. Okay. Okay. So the last part will now be v square equals to what? Ui is always u sin theta, right? So u sin theta all square, then minus what? Minus 2gh. Minus 2gh. Okay, so yes. So this is the vertical motion equation. All right. So please take note. Let me break it. Let me summarize everything. Okay. Since ux, remember, this is the initial horizontal velocity. Initial horizontal velocity equals to what? U cos theta. Initial vertical velocity equals to what? U sin theta. Okay. So when we are deriving resultant motion equation, wherever we see us, we put what? U cos theta. Okay. And remember, I told you guys that in horizontal motion, a is 0, right? So that's why we are left with this other part. I don't know if you understand. Okay. Then in vertical motion, we still have g, because why? Because vertical motion is always affected by g, and g always has downward. So that's why it has negative. That's why it's negative. Okay. Yes. It's not easy. So please take note of these things. So this is the equation under the horizontal motion. Yes, this is the equation under the horizontal motion. While this one is the equation under what? The vertical motion. Okay. Yes, it's very important. Okay. Yes. Now let's continue. This v is the final horizontal velocity, while u is initial. I don't understand. Okay. What about this v? This will be what? The final vertical velocity. Very easy. Okay. So let's continue. Okay. So yeah, now let's continue to the fourth part, which is this category here. So please take note of all this part. Oh, it's very important. Take note. That's why I'm just settling down, like explain these parts. Okay, because we are going to use them. Now let me summarize everything. Remember, horizontal motion does not have acceleration. Yes, it's not affected by acceleration. The vertical motion is affected by acceleration, which is g, and g is always using the first coordinate. Using the first coordinate, going down is negative, right? And I always tell you guys to use the first coordinate. So g is always negative. So that is why you see that all the equation here is negative because of g. Okay. Yes. Vertical motion is affected by g. So it has acceleration, which is g. Horizontal motion does not have acceleration. Okay. So that is very important. Know this part. Okay. So let's move to this fourth part. Okay. I told you guys I've not, thank God, I remember. Now this part here, this was the initial velocity of the body. Okay, when we resolve it to the vertical, we got the initial vertical velocity to be what? Equals to initial velocity sin theta, then the initial horizontal velocity is equals to what? Initial velocity cos theta, right? When we resolve it, okay? Now when the body finally lands, this final velocity, please, is different from these two. Remember, I told you guys that this is the final initial velocity. Sorry. This is the final horizontal velocity, right? Yes. This is the final vertical velocity. Let me recapitulate. Now, this is for the final horizontal velocity. Yes, v is the final horizontal velocity. Why this u here is this u initial velocity. When we resolve to the x-axis, it now carry what? Cos theta. Then this other part, this v is what? Final vertical velocity. Okay, why this u is still this u here? This u is this u. So when we resolve to this side, now be what? U sin theta, right? Yes. Okay. So now let me just label it. Final horizontal velocity. Okay. Then this other one, this v, all this v here is what? Final vertical velocity. Okay. So it's very important. Now, final horizontal velocity, final vertical velocity is different from final velocity. I don't know if you understand. Now, final velocity is the velocity with which the projectile hits the ground. Yes, final velocity and this final velocity so is what the combination of these two guys, combination of the final vertical velocity and what final horizontal velocity. I don't know if you understand. Let me write it. Let me give you the formula of this v. Okay, so in some question we will ask you, they will say a projectile was projected with an initial velocity of this, and then it's calculate its final velocity. When you just say final, know that they're talking about this guy here, and this one is different from all these guys. Okay, now this v here, which is final velocity, is what is v is equal to what root vy square plus what vs square. This vs is this one here, final what final horizontal velocity. Okay, then this vy is what this guys final vertical velocity. So final velocity is what is the square root of what of the square of final vertical velocity plus the square of what final horizontal velocity. Okay, so this is very important, very important. Okay, then so final velocity is the velocity with which the projectile hits the ground. So this is the formula, this is the equation. Okay, yes. Okay, let's which other thing again? In some question, they will give you final velocity. They'll give you this one. They will tell you to look for what? Final horizontal velocity. You look for it. So it's very important. Okay. Now, the angle, the direction of this final velocity. To look for the direction of this final velocity is very easy. Tan theta is equals to vy over what vx. Okay. So theta, which is the angle, now equals to what? Shift tan vy over vx. So this is the what? This is the angle. This is the we can use this angle to calculate for the direction of what of the final velocity. So take note of this part. Take note of this part. Okay. So please, all these things are very important. We are going to use them. Very important. Okay. This part, this part, this part, this part. Okay. Now I'm done with this diagram. I'm done with this part. And let me do this part so we start solving questions. Okay. All right. So now we start with time of flight. Now, what is time of flight? Time of flight is the time it takes what? Remember, please, time of flight is different from total time of flight. Okay. Let me start with maximum height first. Maximum height is what? Is the highest vertical height reached. Okay. So let's say you throw a stone upward now, for example. If you get to a particular height, that stone cannot get above that height. If you throw a stone upward now, for example, so you get to a particular point, it will just stop. Then it will start to fall down. That is what? That is the maximum height. So maximum height is what? Is the highest vertical height. Or let me use, okay, it's the highest vertical height reached by a projectile. The highest vertical height. So you can say the highest height reached by what? By a projectile. Okay? Yes. Now, let me give you guys the formula for maximum height. Maximum height is h equals to u square over what? Over g. Okay, maximum height is what? Equals to what? U square over what? G. Now when it involve an angle, when it involve, okay, yeah, with h equals to u square over 2g, rather, I'm sorry, h equals to u square over 2g. This is the formula for what? This is the formula for what? Maximum height. Okay, yes, formula for maximum height, h equals to u square over 2g. Now when they in a particular question, when they give you an angle, it's very easy. When they give you an angle, so that be what? H equals to u square sin what? Sin square theta all over what? 2g. Okay, so this formula, these two formula are the formula for what? Maximum height. This first one is the formula when they give you, where they didn't give you angle. While this second formula is the formula when they give you angle. Okay, so I've talked about maximum height. Now let me talk about time of flight and total time of flight. Now time of flight is the time it takes a projectile to reach what? To reach the maximum height. Okay, the time it takes that projectile to reach the maximum height is known as time of flight. And time of flight is equals to what? T is equals to what? U over G. This is what? Time of flight. Okay, this is formula for time of flight. Now when it involves an angle, it will now be what? T equals to what? U sin theta over what? Over G. So this is when it doesn't, when they give the question, they didn't add angle in the question. Why this formula? You can use it when they add angle in the question, okay? Then what about total time of flight? Total time of flight is what? Is the time it takes the projectile to reach the maximum height and towards to fall to the ground. I don't know if you understand. The time it takes the projectile to reach this maximum height and to fall to the ground. That's known as what? That's known as total time of flight. And it's what? T. Okay, and it's T. Total time of flight. Wow, this topic is very long. Okay, so let me clean this part. Let me be fast. Okay, let me clean this part. All right. Now, okay, so total time of flight is what? Is the time it takes the projectile to reach the maximum height and to fall to the ground, right? So total time of flight is equals to what? Is equals to if you look at it, this is the time it takes the projectile to reach the maximum height, abi, and the time to fall to the ground, right? So remember, time to reach maximum height is known as what? Is known as time of flight. Yes. Now the time it takes the projectile to reach this height, and from this height to fall, and from the maximum height to fall to the ground is still the same. I don't know if you understand. Yeah, different scenario. Okay, so the time it takes a projectile to reach the maximum height, and from the maximum height to fall to that same to fall to the ground they are the same. So this one is on a time of flight. From here to here, same as time of flight. I don't know if you understand. Time of flight. Okay. When back to that time of flight, the time is the time it takes a projectile to reach the maximum height and to fall to the ground. So total time of flight is what? Is the summation of what? Of time of flight. And if the summation of what? Time of flight. Yes. So one time of flight is what? U over G, right? Another time of flight is what? U over G. So if you add everything, it will be what? It will be 2U over G. So this is what? This is the formula of what? Of total time of flight. 2U over G. Then now when that is when it does not involve an angle. Now, but when it involves an angle, now be what? 2U sin theta over what? Over G. Okay? Yes. All right. That time of flight. Talk about total time of flight. Talk about maximum height. Now let's talk about range. Okay. Now what is range? Okay. Now, let's say you throw a body and that body falls to the ground. And you throw a body from this part and it falls to the ground. Okay. Now, range is what? The distance from here to here is known as what? The range. Okay. So range is what? Range is the horizontal distance from the point of projection to the point where the projectile lands to the ground. Okay. From this point, which is the point of projection, to the point where the projectile lands to the ground. So that's known as what? Range. Okay. So that is known as range. Now, what is the formula for range? Range is equals to what? Is equals to UT. Okay, yes, is equals to UT. This is formula for range. Now, there are about 3 formula for range. Okay, this is one of the formula for range. Okay, then another formula for range is arrow equals to U square sin 2 theta. Okay, sin 2 theta over G. U square sin 2 theta over G. Not my mama car. Mama car is just bad. Okay. So this is the formula for range. Range is arrow equals to UT. Range can also be U square sin 2 theta over G. Okay. Now another formula for range is arrow equals to U square over G. Okay. So one of the formula arrow equals to UT. Another formula arrow equals to U square sin 2 theta over G. This is when it involves an angle. Why this is when it does not involve an angle. Now take notes. This part is very important. If they ask you a particular question and they say calculate for the maximum range, use this formula. Okay, this is formula. So this is the formula for what? Maximum range. Okay, arrow equals to U square over G. Formula for maximum range. Okay. Now take note. This is very important. Range is maximum when the angle is 45. When the angle is 45 degree, range is what? Range is maximum at what? When the angle is at 45 degree. Okay. So this formula and this formula, they are the same thing. This one is gotten from this. I don't know if you understand. Let me how we explain. This one is gotten from this. How? Now, when the angle is 45, when this angle is 45, U square sin 2 times 45 all over G. Now, when this angle is 45, 2 times 45 will give us 90. U square sin 90 over G, right? Now, sin 90, that is, press this in your calculator. Sin 90 is still the same thing as what? As 1. I don't even understand. Sin 90 is the same thing as 1. U squared times 1 will give us U squared. So, this is what? Maximum range. We have arrived to this one back. I don't understand. So, range is maximum when the angle is 45. Okay? Yeah, so if they give you a particular point and they say calculate the maximum range, use this formula. Okay, yes. When I give a particular question, they also and they as they calculate for the range, they involve and they place an angle in that question. Use this formula when it involves an angle. When they just say to calculate for maximum range, use this formula. When it involves an angle, use this one. Then this other one, when they give you velocity and they give you time, they say calculate for range, use this one. Now please take note. This one, so arrow equals to UT. Remember, range is what? Horizontal distance. Horizontal distance. Therefore, this velocity, this initial velocity here, is what? Is the initial horizontal velocity. Remember, what is initial horizontal, which is ux, right? Remember, I told you guys, ux is equals to what? Is equals to u. Oh my god, this marker. Oh my goodness, I'm coming. So, okay, ux is equals to what? U cos theta, right? Yes. So this place here can also be r equals to what? U cos theta, then t times t. Okay. So yes. So this is the formula for range. R equals to ut. R equals to u square sine 2 theta over g. R equals to u square over g. This one is maximum range. This one is when it involve an angle. While this one is when they give you velocity and they give you time, they say calculate for the range. Okay. Now under this scenario, if they give you angle, use this. Okay. When they give you an angle, they give you angle, they give you velocity, they give you time. Use this. Okay. Yes. Okay. That is just it. Okay. That is just it. Okay. So that's all about. This is all you need to know about projectile. Okay. I don't think I'm missing anything. Wait, I think I'm missing something. One last thing before we go move to calculation. One last thing. Okay. All right. Now, this is under maximum height. Okay. So when a body, okay, just take note. When a body is thrown from a particular, when a body is thrown from a tower or from a particular distance or a particular height, okay, well, let's take this. We'll take the total height rather, the total everything, total height. Let me just give this one. Let me call this one h. Let me call this one h. Let me give this one h, for example. Let me give this one let me give this one little letter, small letter h. I'll call it small letter h. Okay, so this one is the height of the tower, while this one is the height it takes to reach the maximum height. I don't understand. From here to here is this h. From here to here, from the ground to this, or let me say this is the height of the tower. While from the tower to the maximum height, that is it. So the total height, the total height from here to here. Let me say that is total height now. Total height. Rather now the total height. Remember this from here to here is still the same thing as well from here to here, right? Yes. So the total height, ht will be equals to what? H plus what? Small letter h. Okay. Where this small letter h is the height of the tower, where this big letter is what? Is the height above the tower. Okay. So yes. So if you add these two, you will get this. I don't even understand. Distance from here to here is still the same thing as distance from here to here. Okay. So when you add these two, you get this. So that is all. Okay. So let's move to calculation.